It's funny. We use Wi-Fi every single day, but have you ever really stopped to think about how it actually works? It feels like pure magic, right? Your phone, your laptop, your TV, your smart toaster, they're all talking at the same time, through thin air, and somehow they don't trip over each other. Well, it's not magic. It's actually an incredibly clever and, dare I say, polite system, a kind of secret handshake that prevents total chaos. And in this explainer, we're going to pull back the curtain on exactly how that handshake works. So here's how we're going to break it down. We'll start with the huge challenge of just talking wirelessly. Then we'll look at the invisible crashes that can happen. After that, we'll reveal the polite conversation that stops those crashes. We'll see how that organizes our networks, and finally, we'll get to see how it all led to the crazy speeds we take for granted today. All right, first things first, the fundamental problem. Think about it. A wired network is kind of easy, right? Every device gets its own private cable, its own lane on the highway. But with wireless, everybody is sharing the same open space, the air itself. So how do you manage that without it just turning into a massive shouting match?
And this really is the billion-device question. I mean, just picture a busy coffee shop. You've got dozens of people on their phones, their laptops, all streaming, downloading, and browsing at the exact same time. Why isn't it just a constant, jumbled digital traffic jam?
Well, what makes it even harder is that Wi-Fi doesn't even get its own private highway. It has to operate on what are called the ISM bands. These are basically public airwaves, frequencies that are unlicensed, meaning anyone can use them. It's less like a private toll road and more like a public park that everyone has to share. And this park isn't just crowded, it's noisy. Wi-Fi isn't just trying to talk over other Wi-Fi signals. It's fighting for airtime with your microwave oven zapping popcorn, old-school cordless phones, maybe some remote-controlled toys, and of course your neighbor's Wi-Fi network that's bleeding right through the walls. It is a seriously chaotic environment. So to understand the brilliant solution, we first have to really get our heads around the single biggest hurdle that Wi-Fi's creators had to overcome. This is the problem that makes wireless a completely different beast than a simple wired connection. And it has a name. It's the villain of our story. We call it the hidden station problem. Sounds simple, but its consequences are huge for any wireless network. This quote gets right to the heart of it. See, on a wired network, the rule is easy. Listen before you talk. A computer listens to the cable. If it's quiet, it's safe to send data. But in the wide open air, that rule just breaks down because you can't hear everyone. Just because it's quiet right where you are doesn't mean it's quiet for the device you're trying to talk to. Okay, let's paint a picture here. Imagine 3 devices. In the middle, you have station B. That's our Wi-Fi access point, the router. On either side, you have station A and station C. Now, both A and C are close enough to the router to hear it, but they're too far away to hear each other. So from A's point of view, C is totally hidden. And from C's point of view, A is hidden. And this is where it all goes wrong. Station A listens, hears nothing but silence, and thinks, awesome, I'm clear to send my data to the router. At the exact same millisecond, Station C does the same thing, listens, hears nothing, and says, perfect, my turn to talk. Their signals fly through the air and, bam, they smash into each other right at the router. The data becomes a garbled mess. It's lost forever. That is an invisible collision. So how in the world do you solve a problem that you can't see or hear? You stop everyone from shouting at once. You create a system of rules, a polite, orderly conversation. And this is the hero of our story. It's called CSMA/CA. Now, that's a mouthful, I know. It stands for Carrier Sense, Multiple Access with Collision Avoidance. And that last word, avoidance, is everything. Instead of just dealing with collisions after they happen, the entire goal is to avoid them from happening in the first place. And it does this using a simple but incredibly powerful process, the 4-way handshake. Honestly, just think of it like raising your hands in class. First, Station A sends a tiny message called a request to send, or RTS. It's basically asking, hey, Mr. Access Point, can I talk for a second? The access point then broadcasts back a clear to send, or CTS. This is the teacher saying, yes, you can, and everybody else, please be quiet.
Only then does Station A send its real data. And finally, the access point sends back an acknowledgement, or ACK, saying, "Got it, thanks."
And this is the absolute genius of the whole system. That clear-to-send message from the router is heard by everyone in the area, including our hidden Station C. So even though C never heard A's original request, it hears that big "be quiet" from the router command and knows to stay silent. The invisible collision is avoided before it ever had a chance to happen. Brilliant.
Okay, so that polite handshake is the secret weapon. Now let's zoom out a bit and see how it's used to build the Wi-Fi networks we actually use every single day.
There are basically two ways Wi-Fi can work. The first is called ad hoc mode. That's where devices just talk directly to each other, peer-to-peer. You know, like two laptops sharing a file on a train. It's simple, direct, but pretty limited. The vast majority of the time, what we think of as Wi-Fi is actually infrastructure mode. And that's where every device communicates through a central boss, the access point.
In infrastructure mode, that access point, your home router, is the indispensable network traffic cop. It's the one managing that whole polite RTS/CTS conversation for everybody. It acts as the bridge to the wired internet, it coordinates all the data flying around, and it keeps the whole network secure and organized. It's the conductor of the entire wireless orchestra.
And this is where the story gets really amazing. Because by perfecting this simple, polite conversation, engineers were able to unlock just staggering increases in speed and performance over the years. Just take a look at this timeline. The very first Wi-Fi standard back in 1997, it topped out at a measly 2 megabits per second. By 2009, with Wi-Fi 4, we were hitting 300 megabits. Then Wi-Fi 5 came along and broke the gigabit per second barrier. And today, Wi-Fi 6 can theoretically hit 10 gigabits per second. This explosive evolution was all built on that foundational principle of collision avoidance. 10 gigabits per second. Let that sink in for a moment. That's a speed that was just science fiction without a physical cable not too long ago. We're talking fast enough to download a full-length 4K movie in just a few seconds. And it's all thanks to devices politely asking for permission before they speak. So, when you boil it all down, that's the secret. That invisible, chaotic world of radio waves was tamed, not by brute force, but by one simple, elegant idea. Don't just shout into the void. Instead, have a polite, structured conversation. It's this handshake that turned a really tough physics problem into the seamless, powerful technology we all depend on. So the next time you connect to a network and it just works, remember what's really happening under the hood. It isn't magic. It's a massive, invisible, and incredibly polite conversation happening at the speed of light. And as we move towards a future where billions more devices in our homes, our cars, or cities all need to join that conversation, it really makes you wonder, what's the next rule we're going to have to invent?